Alrighty, let's take a look at this question. We want to find the solution to this kind of complicated exponential equation. So we have x in the exponent on these two different powers. Now, there are no rules or laws for exponents, or powers, I should say, when you're adding two powers. So we can't really approach this like using exponent laws in that regard. In fact, we are going to use exponent laws, but it's sort of to unsimplify this. So I'm looking at the exponent of x plus 3, and adding in the exponent must have been multiplying two powers before that. So maybe it was 2 to the x times 2 to the 3 before, right? If we're adding the exponents, that could have come from multiplying the two powers. Okay, we're going to do that to this other one as well and see where this leads. Now, 2 cubed, we know that's equal to 8, so I'm going to write that as 8 and I'll put it in front, sort of like a coefficient. So now we have 8 times 2 to the exponent of x plus, and then we'll do the same thing with the second term. 2 to the 4 is 16, I'll put it in front as a coefficient, and then 2 to the x equals 96. Now, we could replace 2 to the x because it is the same for both, or we could look at this as essentially 8 2 to the x's plus 16 2 to the x's would basically be 8 plus 16, so 24 2 to the x's. And there we go. Now we got those two things together. And since x is only in the one term now, we're going to isolate x. First step, we're going to divide by 24 to get 2 to the x by itself. And when we do that, we will have 2 to the exponent of x equals, I think that would be 4. Oh, look at this. Now, we have 2 to the exponent of x equals 4. We can get the bases the same, because 4 could be written as 2 squared. And once we have that, we have a power equals a power. The bases are both 2, so therefore the exponents would equal each other, and that would mean x would equal 2. And there we go. Alrighty, the answer is B, and I hope that helped.